All right, good afternoon again, algebra students. Today we are going to continue solving systems of equations, but now we're going to solve two linear equations by substitution. So in the previous lesson we found the solution to a system of two linear equations by graphically finding the intersection point of the two lines. We graphed them and we found their intersection point. Here we're going to do the same thing. We're going to find the x and y point, but we're going to do it algebraically. So that means we're not graphing, we are going to do it using the substitution method. Okay, so write down this equation and example 1. When y is isolated in one of the equations, then we're going to solve this system by substitution. So here we have y equals 3x plus 4, and then we have x minus y equals 2. We're going to take and substitute when y is isolated, so y equals 3x plus 4. We're going to take that and we're going to substitute it into this equation. So we're going to write x minus, and instead of writing that y, we've got y equals 3x plus 4. So in parentheses, I'm going to write 3x plus 4. I'm substituting y equals for the y in the second equation. So I've got x minus, this is y, equals 2. Now I solve for x. I have to distribute the negative 1 first. So remember, I distribute this. So I get negative 3x minus 4 equals 2. Then I combine like terms, so I combine these two to get negative 2x minus 4, and then I solve. Negative 2x equals 6. I divide by negative 2, and so x is equal to negative 3. But that is only one part of the solution. I need an ordered pair. So I found my x. Now I have to go back into either one of the equations and substitute x. So I'm just going to pick this equation here. So I'm going to let x minus y equals 2. And x is negative 3. So negative 3 minus y equals 2. Then add 3. So I get negative y is equal to 5, which means y is equal to negative 5. So my solution would be an ordered pair. X is negative 3 and y is negative 5. And you've done something like this before in the fall when you were doing perimeter problems. So this is called substitution. All right, let's do two more examples. All right, here are two equations. Now, in this particular situation, instead of the y being isolated, we now have x is equal to y minus 2. So I'm going to take x is equal to y minus 2. I'm going to take this y minus 2 and substitute it in this second equation for the x. So the way this goes is I would do y minus 2 in parentheses plus 2y minus 1 equals 0. So just taking and substituting that entire thing for x, because that's what x equals. Then these parentheses can just go away, and I'm going to combine like terms and then solve for y. So combine the y and the 2y, I get 3y. Combine negative 2 and negative 1, I get negative 3 equals 0. Then add 3. So I get 3y equals 3, which means y is equal to 1. Now I have the y, but I need the x. So I'm going to take over here, and I'm just going to do this equation. You can do either one, it doesn't matter. So x is equal to, y is 1, y minus 2. So that means x is equal to negative 1. So now I have a solution to the system of equations is an ordered pair, and this is where those two lines intersect. All right, one last example. Okay, so when you have a situation, as we do here, we have two equations, write them down, and you can see that neither one is really isolated. So you don't have x equals something, you don't have y equals something, so they're not isolated. So what you're going to do is you're going to look at the equations and you want to look for an x or a y that has a coefficient of 1. So you want to look for an x or a y that has a coefficient of 1. Well, this has a coefficient of 1, that has a coefficient of -3, that has a coefficient of 2, that has a coefficient of 7. So I need to find the coefficient of 1 because it's the simplest to do. So I'm going to solve for x right here. So if I have x minus 3y equals 4 and I solve for x, that means I'm just going to add 3y to both sides. It doesn't matter if you solve for x or y, you're just looking for the simplest to do. And the simplest is when you don't have a number for the coefficient, you just have 1. So now I've isolated x. Now I'm going to take this isolated x, this 3y plus 4, and substitute it into the other equation where the x is. So I would do 2 times x, and x is 3y plus 4, and then I finish my equation, plus 7y equals -5. Now I solve for y. So I distribute again, and then I combine like terms, and then I solve. So subtract 8, I get 13y is equal to -13. So if I divide by 13, I know that y is -1. Now I take this y is -1 and I substitute it back into either equation. It doesn't matter. I'm going to pick the first one. X minus 3, y is -1 is equal to 4. So this is x plus 3 is equal to 4. So subtract 3 and I get x equals 1. So my solution is 1, -1. And you can always check the solution by plugging this point back into both of those equations to see if you get a true statement. All right, so that's our lesson for today. I'm sure you will enjoy your assignment, so have a great day.